Did y'all find this helpful? This how I used to teach this class when I first did it. I just used to stand right here and use my paper, and I didn't have PowerPoints, but now we do. Now we do because your seniors want PowerPoint. So yeah, I sent this before class started. Okay. So guys, don't forget, because I do have old resolutions on there. So know your resolutions too. Know the alternate names. Know your Lord. Know your Lord. Know your ladder. Know those lateral, angular, transverse, azimuthal. Okay, know your Lord. Longitudinal, axial, range, radial, depth. Okay, know that because I'm not asking you direct. Hey, this is lateral. This is elevational or slice thickness. Spatial detail. Know that what are our two types of spatial resolution? Our detail resolution. What are our two types? I talked about this a little bit last semester. Axial and lateral. Those are two types of spatial resolution. Those are detail resolution, right? Axial and lateral are two types of detail resolution.
So we have to go back to that chapter?
Right, I'm telling you right now. I'm telling you right now. I'm doing my mental review on the test right now. What else I got? But just that quick, that's the chapter right there. Yeah, just that quick, man. That's the chapter right there. We went through the whole chapter right there. That's it. That's it right there. You guys wanna y'all already did your homework already? Y'all have any questions on the homework? Any questions on the homework? I'm telling you. Y'all should just take it Wednesday. Give yourself more time to study. What's number 14 say?
When the frame rate is 75 electrons per meter frame, would it just be 1 over 75 centimeters?
Yeah, you can write it like that.
Is that 12 and 14 in the book? The same?
Let me see. 12 and 14.
One had about T-frame and the other one is
12 and 14. I mean, you're going to calculate them pretty much the same, but what is the time needed to make a single image if the frame rate of an ultrasound is 50 hertz? 1/50th of a second? Or what's
0.2.
0.2?
Yeah, 0.2.
0.2? 1/50th of a second? Yeah. You can do it like that too. Have you guys been looking in the question in the back of the book? Cause it got some good questions back there. It has some good questions back there. Let's check them out. Let's check some out. What page are they on? In the back of the book? You okay? You cold? You can come up here with me and help me. Come out, man. I know y'all ready for this test. I know y'all ready for this test. Okay, it's on page 504, guys. Let's just do a couple of these. Oh, it ain't that many anyway. So let's see which ones I like. Like I said, guys, it's hard for me to make a bunch of questions off of this test. I would say this should be, how I like to start the semester off with confidence, giving you guys confidence. That's what this test is going to be. It should be 13 A's in here. 13 A's in here. Remember our relationships that I had on the board. 13 A's. Just make sure you read carefully. Read carefully. So that's 392, guys.
Can I ask a question about the homework before we go there?
Go ahead.
The first question, the answer is it the T-frame?
I don't know. I don't have the homework question. Y'all just have
Say
it.
the process of image being displayed one frame at a time.
Static.
Static.
What's that, Mrs. Lee? Okay, I thought you had another question.
Yeah.
Okay, another.
No.
It's cold in here. It is cold in here.
The second one is an ultrasound photograph is too blank as a movie is too
Real-time images. Real-time static and real-time images.
And the first blank is static and then
It's not 2D and SynLook.
2D is a static image. You can say 2D too. That's a
So
static image.
I put 2D and SynLooks, okay?
Yes.
static.
Actually, no, I don't like that, dude. Because 2D is a mode. 2D is like it's B scan. It's like it's one of our display modes. That's how grayscale image is, right? It's not because even our ultrasound movies can be in 2D. Okay, so I like static.
Okay.
I like static. All right, guys. Number 392. Which of the following will improve a system's temporal resolution? Man, it is chilly in here. Goodness gracious. Goodness gracious. Goodness gracious. Guys, if you can, try to put your hand over the correct answer if you can. Put your hand over the correct answer if you can. I'm on page number 392, page 504. Which of the following will improve a system's temporal resolution? Increase sector angle, increase line density, increase PRF, increase frequency. So it's C for sure. But even without thinking about it, when we're talking about temporal resolution and frame rate, we know that our system's control settings are inversely related to it, right? So if I want to improve temporal resolution, then I'm not going to increase any of my system control settings, right?
Right.
So any one that has sector angle, line density, and frequency don't have nothing to do with it, right? Frequency is a acoustic parameter, not a pulse parameter, right? And we're talking about pulses right now. Okay, so of course PRF for sure because
This will increase.
I'm able to increase. I'm able to send more pulses per second now. Okay, I'm able to send more pulses per second. And if I'm sending more pulses per second, then I'm also acquiring more frames per second. Right? So that means I'm able to send and receive more often in a less amount of time. Okay? Remember I was telling you the other day I can add PRP and PRF to the board as well. I can add duty factor to that board as well. Because if I'm sending more pulses per second, now my machine, the fraction of time that it's working, my duty factor is going up now, right? Because it's sending more signals, it's sending more pulses. Okay. So I like these true or false questions because when I was looking over these, it got me a couple of times because you know how you try to read over something real quick and you don't read, in depth. Y'all was just like, oh, that's true. Okay. So true or false? An ultrasound system with a longer pulse duration will generally have better temporal resolution. That's the one that got me right there, because I just immediately answered the question, not thinking that pulse duration don't have anything to do with our temporal resolution, right? It's a fixed number.
This number of poles.
Okay. Only thing that has something to do with temporal resolution would be our listening time, right? Our listening time, because that's the only thing us as a sonographer that we could change, right? Our pulse duration isn't going to matter because that depends on how far. Our pulse duration can be, however long, but if the signal has to go to a certain depth, no matter what, it's going to travel at the same speed, right? So it's going to get there and back at the same time, no matter what. Okay. So number 394, the length of a pulse does not directly influence the temporal resolution.
True.
That's just the same question, opposite
True.
way. That's just the same question, opposite way.
Oh.
So there's something I would say about the question in the back
True.
of the book that I don't always like. You can tell that Mr. Edelman, he's trying to trick you with some of these questions, But I guess they make you think, so that's a good thing. So here go one with a number. 2 imaging systems produce acoustic pulses. One pulse is 0.4 microseconds long, and the other one is 0.2 microseconds long. Which is most likely to have the same question again, guys.
With the shorter.
All of that information, it can't be determined because it's still asking us about post duration. And post duration, what does post duration affect?
Sector, right?
What resolution is post duration affect?
Lateral.
Axial resolution.
Action.
Axial resolution.
So this is question.
Axial resolution. Okay. Because spatial pulse length determines the axial resolution, but spatial pulse length and pulse duration, they look exactly the same when you're looking at them, right?
Mm-hmm.
So that in that case, you can say they have a relationship that's a direct relationship. What two factors determine temporal resolution? Speed of sound and the depth.
Depth of field.
Speed of sound and the depth. Okay. What two controls determine the system's temporal resolution? D. So know the difference between those, because one is asking you about the factors that determine temporal resolution, and one is asking you about the controls that can be adjusted that affect temporal resolution. Okay? So know the difference between both of those. An ultrasound system with a shorter PRP, basically meaning the listening in a less amount of time, will have better temporal resolution than a system with a longer PRP. I'll give you guys a little time to marinate on it. If I have a shorter PRP, let's say these are both my go times.
Yeah. It chew.
Short, long. Which one of these is gonna have the better temporal resolution?
The
The
short.
one with the shorter PRP, right?
Mm-hmm.
Because it's gonna be the listening time is less,
Right.
so it's gonna be able to come back to the transducer faster, helping me acquire images faster as well. Spatial pulse length. Spatial pulse length. Okay. What is the primary disadvantage of multiple focal zones down each scan line? 399. Improved temporal resolution.
Decrease.
Decreased temporal resolution. Improved lateral resolution. Improved longitudinal resolution.
B.
B, guys. B. The primary disadvantage is if I have multiple focal zones, then I'm decreasing temporal resolution because it's taking longer now. What if I would have said increase the time it takes to create one image? Is that true?
Is it?
What is longitudinal resolution?
Axial.
Axial resolution. Axial resolution. Okay. Primary advantage of multiple focal zones is, of course, C, improved lateral resolution like that. Got number 408. Number 408.
Wait, what's 399?
399. Oh, I'm sorry. 399 was B. B. The primary disadvantage of multiple focal zones is that I'm decreasing the temporal resolution because I'm decreasing my frame rates. All right. Number 408. This is one like I was just kind of talking about right here. A sonographer reduced the sector size from 90 degrees to 30 degrees. Frame rate, however, did not change. What else happened? So we automatically know if I go from 90 degrees to 30 degrees, my frame rate should increase, right?
Mm-hmm.
Then that means for nothing to happen, that means I had to do something that increased the frame rates to keep it even, right? So let's look at our answers. My imaging depth decreased, my pulse duration increased, the multi-focus was turned on, or the PRF was increased. So which one of the sonographer control settings did I adjust to counteract me decreasing my sector size?
So
answer should be C, the multifocus, because I have to counterbalance that, right?
Mhm.
I'm decreasing the sector size, which is gonna increase my temporal resolution.
Right.
But it's telling me that my frame rate didn't change, meaning my temporal resolution didn't change. So that means another scenario, whether I adjust my imaging depth, whether I adjust my line density, or whether I adjust my multifocus, one of those are gonna have to change because those are the user controls that can be affected. That's mine.
Yeah.
Just click my little button on the side. Click my little button on the side. Okay. I'm trying to access something. Okay. Which one?
Say it again. Shepherd.
I mean, I have a game. We're playing a game on Wednesday. We're playing a game on
Not
Wednesday.
today.
Yeah, not today
Oh, it's
because
today.
I want it because I don't want to have a game and people don't know the questions. People don't know how to answer the questions. So we're gonna play the game on Wednesday. Today is our review before the review, pre-review day. Pre-review day.
Too much review.
Okay. Number 404, guys. Which of the following sector imaging systems will have the best detail if all other parameters are identical? I like these kind of questions. 404. Which of the following will have the best image detail if all other parameters are identical? Why, Pat?
The smallest.
A lot of poses, right? Small sector, a lot of poses. 60 and 60, yeah, my sector which is small, I'm gonna have some good. Well, actually, the detail only matters with the number of pulses, really. But if I have a 90-degree sector and 100 pulses, then I'm still gonna have a lot of space between those, right? But if I have a 70-degree sector and 84 pulses, then I would say the thing that makes it right to me is that my pulses exceed my sector width. Right, so I'm gonna have I may have overlap on those, right?
Smallest.
I may have overlap. I have more scan lines per every degree on my sector width. You got me? So I'm gonna have some overlap.
So this means your light density is.
It's gonna be high.
Yeah.
So that's what affects image detail. That's what affects spatial resolution. And my line density is high. If I got a lot of spokes in that wheel, then that means I'm gonna be able to get better image detail. I'm gonna have a better image. If I don't have much space between those spokes, then I'm missing a lot of information, and the machine has to make up that information.
Wait, you say high in this density, light density is better ratio?
Better spatial resolution.
Okay.
It's worse.
Detail, you say detail.
Yeah. Remember, I'm using those terms interchangeably, but it's worsening my temporal resolution with
Yeah.
with more line depth.
Right,
higher line
right,
depth.
right. Because the 60 is like, it's bigger, right? If the light
Like
density is.
how I'm kind of doing it, I'm kind of just dividing the number of scan lines into my sector size
Mhm.
because that's going to determine and maybe I overthink about it. I'm thinking too much because I'm basically with D. I'm going to have one scan line per degree, right?
Mhm.
So I'm have my field of view is 60, and I'm going to have 60 pulses. So every degree, I'm going to have a scan line,
Mhm.
right? So that one's probably going to break even. But when I look at the first one, I have a 90-degree sector with 100 scan lines. That's pretty good too. That's pretty good too. But the fact that I have a 70-degree sector, I would just divide those numbers, and that's how I would determine which one is going to have the best detail resolution. Too geeky. Too nerdy. No questions, guys? The easiest test of the year right here. The easiest one of the year. It's our first test of the year, so it should be, right?
So it'd be
The easiest test of the year right there is 100. 100. She's thinking that she's gonna get a 100. Ooh, 100. I know Sophie ain't gonna get a 100.
Of course, it's
I know Sophie ain't gonna get a 100.
Mr. Pickett,
Yes, ma'am.
how we get the 84 over 70?
Everybody. Everybody.
How we get to the 84 over 70 on this,